is this?
My oil refinery.
An oil refinery? Who even builds oil refineries with their plates? Why would you even need to know enough about it to build a model of it?
Oil is important. How else would you get to school every day? Clicks, plastic bricks. Plastic is made from oil.
Okay, yeah, oil is important, but you don't need to be building oil refineries with your plates.
I do too. Reinforcing my knowledge of chemical engineering.
Why? Why do you even want to be a chemical engineer?
Oh, I don't know. Maybe so I can be awesome and take over the world. Like the president of China, he's a chemical engineer.
Okay, genius. Then tell me how an oil refinery works.
I suppose I can give you a crude rundown. Alright, so you have two main processes, upstream and then downstream. Upstream is getting the oil from the ground or wherever, and downstream is the oil refinery, processing all the raw oil so that it can be used for fuel products and products like plates and cars. In the oil refinery, there are three main processes. The crude oil goes from separation to conversion to purification. The separation process happens by way of a fractional distillation column. Are you taking advanced chemistry this year?
Yeah, why?
Your teacher will probably show you distillation at some point.
Yeah, she said it's kind of like to use water after every watercolor painting. After mixing all the paint distillation, it's like trying to reverse the process and get each color back.
Yep, all the different colors in the mixed water, aka the crude oil, have different boiling points because of their chemical properties, mainly their molar mass. The crude oil is boiled so that all of it is vapor and passed through the distillation column. As the gas rises through the column, it passes through trays that collect the liquids as the gases of the different components of the crude oil cool down. Heavy molecules have a higher boiling point, so they condense more quickly and will be on the lower levels of the column. Asphalt is one example.
So then lighter molecules would condense farther up the distillation column where the temperature is lower since their boiling points are lower, right?
Yes, exactly. Gasoline would be an example here. That's separation. You can't always get what you want, though.
You can't always get what you want.
No, but you can get what you need. That's where conversion comes in. There are three main conversion processes that can be used on streams from the separation process. Cracking is the most common conversion process, and as the name implies, it breaks oil molecules into other different smaller oil molecules. There's also unification, which is the opposite sort of thing, taking small oil molecules and making bigger ones. Lastly, there's alteration, which takes one stream but rearranges the way the molecule is to make something different. After all that magic, there's the purification process. There's still a lot of stuff left in the streams that isn't wanted, like sulfur, nitrogen, water, and dissolved metals, mainly sulfur. There's a little more magic, aka chemistry, that the streams go through. And from there, we get all kinds of products. Shoes, shampoo, diapers, guitar strings, even car tires, and plastic bricks. Ta-da!